Hello and welcome back. In this lecture, we're going to take a high-level look at the game architecture and course structure. The creator of Stardew Valley took over 4 years to build one of the most famous farming RPGs around. This course and game project took thousands of man-hours to build, and at the end of the course, you will have explored and built many of the main systems required to build a farming RPG game. This course will save you many months of development, and you can take the completed project and carry on developing it into your own unique production-ready game. This course is a project-based course, and each lecture takes the game from the previous lecture and adds new functionality. If you are building your own project as you follow the course, you will need to start at the first lecture and then complete each subsequent lecture in turn. Each lecture will present all the configuration you need to complete in the Unity editor and the C# scripts you will need to create or update. The supplied completed project has been created using a Git source control repository, so you will also be able to see the code changes for that lecture using the source tree client that we have recommended you install to follow the course. The first course lectures will get you to set up an empty Unity project and install the required packages, including the custom package we supply that provides all the assets you will need to complete the project, including sprites, animations, and sounds amongst other things. In the player section of the course, we'll set up the player game object and its child game object hierarchy. We'll create an abstract class singleton pattern that we'll use for the player component and other game managers, and implement player movement using events. We'll also set up the player animations using animator components and animation controllers. In the game scenes and tilemap section of the course, we'll create a hierarchy of tilemaps to use when creating game scenes. We'll create the farmyard scene, add collision tiles, add scenery, and use Cinemachine camera functionality to keep the camera within the scene bounds. We'll also create a fader to fade scenery when the player moves behind things. In the inventory and items section, we'll set up everything to do with items and inventory. We'll define the classes needed to represent items and use scriptable object assets to store a list of items. We'll create prefabs to add items to the scene. We'll create an inventory manager that will contain core functionality for managing items in inventory. We'll create a custom property attribute drawer to help our workflow. A UI inventory bar will be created to show what items the player has, and we'll add functionality to pick up, drop, reorder and select items on the inventory bar. We'll use animation overrides to show the player holding the selected items. In the game time system section, we'll create a game time system that generates time-related events and display a game clock UI. In the scene management section, we'll create a scene controller manager to load scenes and unload scenes as we move between multiple scenes. We'll also create a new field scene and cabin scene for the game. In the preserving scene state section, we'll implement functionality to save the state of items in scenes as we move between them. We'll use a C# interface to define what properties and methods an object needs to implement to have its scene state stored and restored. In the Tilemap Grid Properties section, we'll implement a system to allow properties, such as where an item can be dropped, to be painted onto special tile maps to provide an easy visual workflow to capture different tilemap grid properties. We'll also implement a grid cursor to use these properties to show the player where items can be dropped. In the Using Tools section, we'll start implementing the farming tools that the player can use, such as the hoe to dig ground, the watering can to water ground, and the scythe to reap grass. In the Pool Manager section, we'll create a pool manager that will allow a pool of prefab objects to be defined and reused, and explain why reusing objects can be more efficient than creating new objects. In the VFX Manager and Particle Effects section, we'll start creating particle effects for the game, and we'll build a VFX Manager that will be used to display the harvest action effects in the game. In the Crops section, we'll cover everything to do with planting, growing and harvesting crops. We'll define the classes we need to represent crops and store crop details in a scriptable object. We'll add functionality to plant seeds in dug ground and then harvest crops when they are fully grown, collecting them in a basket. This section also includes planting, growing and chopping down trees, and we'll add the axe tool to enable this. We'll also add functionality to allow crops to transform into other crops when they're harvested. For example, a chopped down tree becomes a tree trunk that can also be chopped. We'll also implement rocks as crops that can be harvested with a pickaxe. This is a big section of the course and covers a wide range of functionality. In the Pause menu section, we'll introduce a pause menu when the player presses the escape key. We'll add a full inventory management screen to the pause menu and a quick game option. In the Save Game section, we'll implement everything needed to save the game to a file on disk and load it again. This functionality uses a C# interface to define all the properties and methods an object needs to have to be able to save its game state. We'll use C# binary serialization to convert all the class data to a file on disk, and deserialization to load it back again. Game saving functionality could be considered a course in its own right, but we provide you with all the code and information you need to implement a save game system. In the Player Customization section, we'll show you how to implement a full player customization system that allows you to customize your player character's shirt, trousers, hairstyle, skin color, hat, and adornments like glasses. In the Pathfinding for NPCs section, we implement A-star pathfinding and time-based schedules for our game NPCs, Butch and Cora. We start by talking through pathfinding in 2D games and then quickly move on to the A-star pathfinding algorithm and how it can be built and implemented for the game. We provide another downloadable Unity project that you can use to demonstrate A-star pathfinding and see how the algorithm calculates the best path. This is then developed further and implemented for the game. We also add schedules to trigger NPC movements when time-based events occur. This section is comprehensive and a course in its own right. In the sound effects and music section of the course, we start by looking at the audio concepts in Unity. We then add player footstep and action sounds to the game. This section rounds off by adding ambient sounds and game music for scenes. So this is the game architecture and course structure that we'll be working on, and I look forward to seeing you in the next lecture.